Space is vast, but it's not empty. 3 Chinese astronauts known as taikonauts recently discovered this in a very personal way. Wang Jie, Chen Zhongrui, and Chen Dong were preparing to come home. They had spent 6 months aboard China's Tiangong space station. Their mission was a success, filled with scientific experiments and spacewalks. They were performing final checks on their Shenzhou-20 return capsule. It was November 5th, 2025, just moments before they were supposed to undock and begin their fiery journey back through Earth's atmosphere. Suddenly, something went wrong. A small but powerful impact occurred, striking the very vehicle meant to bring them safely back to our planet. The cause of this alarming event was a piece of orbital debris. It was a tiny, rogue object hurtling through the vacuum of space. The collision left a visible mark on the Shenzhou-20 capsule's exterior hull. Immediately, the planned re-entry was called off. The safety of the crew became the absolute top priority. While the taikonauts, Wang, Chen, and Chen, are reported to be safe and in good health, their return to Earth is now indefinitely postponed. They are stranded hundreds of miles above the ground, waiting for engineers to figure out if their ride home is still space-worthy. It's a stark reminder that even the most carefully planned missions can be disrupted by the smallest of hazards. For now, the stranded crew is not alone. Fortunately, their replacement crew, the Shenzhou-21 mission, had already arrived at the Tiangong station a few days earlier, on October 31st. This means the space station is currently hosting 2 full crews. This overlap, while not originally planned for this long, has become a critical advantage. The newly arrived astronauts are now assisting their colleagues. Together they are conducting detailed inspections of the damaged capsule. Using the station's robotic arm and other tools, they are trying to understand the full extent of the damage. Their collaborative work is essential for the next steps in this unexpected and tense situation. The China Manned Space Agency, or CMSA, is now in a race against the clock. Their experts on the ground are analyzing all the data being sent from Tiangong. They need to perform a thorough risk assessment. The visible mark on the outside is one thing, but the real question is about hidden damage. Is the capsule's heat shield compromised? Are there any internal systems that were affected by the impact? A safe re-entry requires the capsule to be in perfect condition. To address this uncertainty, the agency has activated a backup plan. A brand new spacecraft, the Shenzhou-22, is on standby, ready to be launched on a Long March 2F rocket for an emergency rescue if needed. So, what exactly is this space debris that caused such a serious problem? Think of it as space junk. It's a collection of all the man-made objects left in orbit that no longer serve any useful purpose. This includes old defunct satellites that have stopped working. It also includes spent rocket stages that were discarded after launching their payloads. Even tiny flecks of paint that have chipped off spacecraft are considered debris. Over decades of space exploration, we have filled the orbits around Earth with this clutter. These objects don't just float peacefully, they travel at incredible speeds, making them very dangerous. The danger comes from their velocity. In low Earth orbit, where the Tiangong station and the International Space Station, or ISS, reside, objects travel at speeds up to 17,000 miles per hour, or about 27,400 kilometers per hour. That's more than 10 times faster than a rifle bullet. At such high speeds, even a very small object carries a huge amount of kinetic energy. A paint fleck, for example, can create a small crater in a spacecraft window. A slightly larger object, the size of a marble, could penetrate the hull of a space station. The piece that struck the Shenzhou-20 capsule was likely small, but its high speed was enough to cause significant concern. The amount of this debris is truly staggering. Official tracking agencies, like the one in the United States, are currently monitoring about 19,000 large pieces of debris. These are objects big enough to be seen with ground-based radar, typically larger than a softball. However, NASA estimates that there are over 500,000 smaller fragments between the size of a marble and a softball that are too small to be reliably tracked. and the number of particles smaller than a marble could be in the hundreds of millions. Each one of these untracked pieces is a potential bullet, posing a constant threat to active satellites and human spaceflight missions. This problem is not new, but it is getting worse. This recent incident with the Chinese taikonauts is part of a pattern. It's actually the second time in 2025 that astronauts have been stranded because of a damaged capsule. Just 7 months prior, 2 NASA astronauts, Suni Williams and Butch Wilmore, faced a similar situation on the ISS. Their capsule also had issues that delayed their return. These events highlight a growing vulnerability. As we launch more and more satellites and missions, the orbital environment becomes more crowded and more hazardous. The sky is big, but the useful orbital paths around Earth are a finite resource that we are filling with dangerous junk. The history of space exploration is filled with close calls and direct hits from orbital debris. These incidents show that the threat has been with us for a long time. During the 1980s and 1990s, Russia's Mir space station reported numerous impacts from small debris particles over its lifetime in orbit. These were often minor strikes, but they served as early warnings about the dangers of our increasingly cluttered orbital environment. Space agencies began to understand that even microscopic impacts repeated over time could weaken a spacecraft's structure. These early events laid the groundwork for the shielding and debris avoidance procedures used on space stations today. More recently, the incidents have become more frequent and more serious. In 2021, the International Space Station's large robotic arm, Canadarm2, was struck by a piece of debris. The impact left a clear hole through the arm's thermal blanket, and boom. Luckily, the arm's electronics were not damaged and it remained operational. It was a lucky miss. Then, in 2022, a docked Russian Soyuz spacecraft at the ISS suffered a major coolant leak. The cause was determined to be a micrometeoroid, or a tiny piece of debris that punctured an external radiator. This incident forced a change of plans and required an empty replacement Soyuz to be sent up for the crew's return. The Shenzhou-20 incident is the latest chapter in this ongoing story. The Tiangong space station, whose name means Heavenly Palace, has been orbiting Earth since 2021 at an altitude of about 250 miles, or 400 kilometers. It is a modern marvel of engineering, operated exclusively by China. However, even the newest and most advanced hardware is not immune to the random threat of space junk. The fact that a critical return vehicle was damaged highlights the vulnerability of all space assets. It doesn't matter which country owns the spacecraft. Orbital debris is an indiscriminate threat to everyone operating in space. The problem is compounded by a phenomenon known as the Kessler syndrome. This is a scenario proposed by NASA scientist Donald J. Kessler in 1978, where the density of objects in low Earth orbit becomes so high that collisions between objects could cause a cascade. Each collision would generate more space debris, which in turn increases the likelihood of further collisions. This could create a chain reaction, eventually rendering certain orbits unusable for generations. While we are not there yet, every collision, like the one that hit the Shenzhou-20 capsule, pushes us a little closer to this dangerous tipping point, making future space travel and satellite operations much riskier. The immediate priority for the China Manned Space Agency is the safe return of astronauts Wang Jie, Chen Zhongrui and Chen Dong. The ongoing analysis of the Shenzhou-20 capsule will determine the next course of action. If engineers decide the damage is superficial and poses no threat to the crew during re-entry, the mission may be cleared to return. This is the best-case scenario. However, if there is any doubt about the capsule's integrity, especially its heat shield, the risk is too great. The capsule must withstand extreme temperatures and pressures when it re-enters the atmosphere, and any weakness could be catastrophic. If the Shenzhou-20 is deemed unsafe, the backup plan will be fully implemented. The CMSA has a rolling backup mechanism, a testament to their focus on crew safety. This means that the Shenzhou-20 spacecraft and its Long March 2F rocket are already being prepared for a potential launch. This rescue mission would fly to the Tiangong station without a crew. Once docked, the 3 stranded taikonauts would transfer from the station to the new undamaged capsule. They would then use the Shenzhou-22 to return to Earth, leaving the damaged Shenzhou-20 behind to be disposed of later. This approach ensures the crew has a reliable vehicle for their journey home. Beyond this specific rescue, the incident forces a broader conversation about how we manage the space environment. We need better ways to track smaller pieces of debris. We also need to develop technologies to actively remove junk from orbit. Several concepts are being explored, from satellites that can capture debris with nets or harpoons, to lasers that can nudge junk into a lower orbit where it will burn up in the atmosphere. These solutions are complex and expensive, but they may be necessary to protect our future in space. International cooperation will be key, as this is a global problem that requires a global solution. Ultimately, this event underscores the need for responsible behavior in space. Every nation and company that launches objects into orbit has a duty to minimize the debris they create. This includes designing satellites that can de-orbit themselves at the end of their lives, and avoiding deliberate actions that generate more junk, such as anti-satellite missile tests. The final frontier is a shared resource. To keep it safe for future generations of explorers, scientists, and astronauts, we must treat it with care. The rescue of the Shenzhou-20 crew will be a triumph of engineering, but the real victory will be learning from this and working together to clean up our cosmic backyard.